Okay. So, in the GeoGebra activity, today we're going to be talking about cross sections. So, last week before Thanksgiving, I had you guys do that quizzes where you were talking about all the different 3D shapes. It's good to know that. What a cross section is essentially this. If you were to cut a shape in half, a 3D figure in half, and look at it dead on, what 2D shape does it make? All right, that's basically all a cross section is. It's actually pretty straightforward. All right. Now, we're actually going to do this activity together as a class. Okay, so my screen looks a little bit different than y'all's, but this should be what it looks like for you guys. All right. So we're just going to do the cross section part first. So you just need to click on this first part right here. So the very first thing after table of contents, you should see this screen. So click on the first thing underneath table of contents. You should see this screen. Is everyone there? All right. So again, you also need your packet out, page 9, because this goes along with it. So we're going to go back and forth between this and the figure. So with this activity, it actually is pretty cool because this tool allows you to actually go through and kind of play with the different cross sections and figure out what's going on. So we're going to do a couple together, then I'll have you guys do a couple on your own, just so you kind of know what you're doing. Okay? So we're going to start with a rectangular prism. So go ahead and click on sections of a rectangular prism. And you should see something like this. I'm going to full screen mine. All right, you should see this. Now, it's nice because you can move it around with your mouse if you grab it. All right. This plane right here, this little blue thing right here, this is called a plane. That's what's actually cutting through the rectangular prism, which is the yellow part. All right. So if we look at what it's asking us to do first, parallel to the base. So they want us to put the plane parallel to the base. Now, we talked about this last week. What is the base of a rectangular prism? So in other words, what's its main shape? A rectangle. So what I'm going to do is that we just want it parallel to the base. So it doesn't matter where. We're going to say that this rectangle right here on top is the base. So that means the bottom one's also the base. So it looks like it already is. All right. Now, you can move it around a little bit too, however you want. Now, what we're going to do is actually look at the cross section. So what you're going to click is view from cross section. What shape is that? That is definitely not a square. It's a rectangle. So that's what we're going to write. The cross section that we get if we cut a rectangular prism in half parallel to its base and look at it dead on, we get a rectangle. Now we're going to look at it vertical to the center. So I'm going to move it back so that I can see what the shape looks like. And I want it to be vertical to the center. So what I'm going to do is I'm going to rotate the plane so that it's completely vertical. So I'm going to go all the way from horizontal to vertical. And I'm going to kind of eyeball it and make sure that it's centered. So it's not quite center, so I can move it a little bit. So if I move it about right there, it would be centered. All right, we're trying to make sure that it cuts in half. So if we move the plane a little bit, about right there. All right. So once we get it as best as we can to the center and it's vertical, we're now going to look at its cross section. So you're going to hit view from section. What shape is that? Rectangle. So if we cut it vertically through the center, it'll be a rectangle. Now, perpendicular to the base, that just means the plane itself will be 90 degrees. So straight up vertical, but it's just not going to go through the center. So all we're going to do is take this, move it back, and we're just going to offset it so that it's not quite at the center. All right, so I'm just going to offset this just a little bit. So about right there. Yours doesn't have to be the same as mine as long as it's not at the center. And then we're going to view from the section. So what shape? Rectangle. Now, rectangular prism, most of these are going to be rectangle. Now, the last one is through its diagonal, so from corner to corner. So, in other words, it's similar to the diagonal of a rectangle. So, we're going to turn it again. All right. We're going to rotate it so that it's going diagonally as best as we can, and we're going to move it as best as we can so that's from one corner to the other. So my suggestion is get it to it's that at one corner and then rotate it again until it's at the other corner. You may have to play with it a little bit. So just get it as best as you can. All right. So I got it as best as I could. All right. Yours doesn't have to be perfect. Just try and get it as best as you can. All right. Now, if we view from the section, what do you think it's going to be before I even do it? All right. So some say triangle, some say rectangle. It's a rectangle. All right. So a cross section again, guys, if this plane is a knife and we're cutting through this shape using that plane, and we looked at what the shape of it is directly head on. So in other words, think about if you were doing like a bird's eye view. If you're looking at where you cut from a bird's eye view, what shape would it be? That's what we're looking at. All right. Now, that was a rectangular prism. Now, play with it for a minute and see if you can find any others that create a shape that's not a rectangle. So play with it for a minute. Just move the plane around as much as you can. See if you can find one that's not a rectangle. So see if you can find any other cross sections that are not rectangles.
Have you seen?
So take a minute. Play with it. See if you can find another cross section that's not a rectangle, a rectangular prism. So whatever ones you find, they're not a rectangle, you can list it. Just any others. So some have found a diamond, some have, or a pentagon, but it looks like a actual diamond gem. Some found squares. Some of you are getting some trapezoids. There's really no correct answer. I just want to see if you can find one. We'll look at it from the cross section. That's a parallel grid, so it's not a right angle, it's a parallel. Yeah. All right, so come back together. So someone raise your hand and tell me one shape that they found that was not a rectangle. Brayden. All right, you could get a square. Someone else. There is trapezoids. You could get trapezoids. What else? Anyone? Parallelogram. What else? Anyone else find anything different? There's a gem-looking diamond. So in other words, it's a pentagon. Or no, it's a really weird hexagon. No, it's pentagon. Yeah. All right. So those are just some that you could have found, but you would have to cut it fairly weirdly. All right. All right. So now let's go and do, let's see. So let's do a triangle prism next. So over here, we're going to hit triangle prism. All right. So if we're going to do a triangle prism, first things first, since I showed you what you're going to do, now I'm going to have you guys try it one by one. So take a minute, do parallel to the base. So first off, what would be the base of the triangle? The triangle prism, the base is a triangle. So if you want parallel to it, that means it's not going through the triangle side. All right? So go ahead and find what the cross section is if it's parallel to the base. All right, what'd you guys get? Triangle. Good. So, planes parallel to the base, if I view from the cross section, it's a triangle. And I know it's not on here, but we're still just playing with it. All right? Now, what about if it's vertical through the center? So, try and get as best as you can to be centered through the triangle, but I want it to be completely vertical. So, center will be about right here. So, what do you think your cross section is going to be? It's definitely going to be a rectangle. All right. If we do perpendicular, so slightly off. So, if we move this slightly off, what do you think it's going to be? Still a rectangle. All right. Now, then if we go diagonal, so get it as best as you can. What shape do you think it's going to be? It's a triangle. All right. Now, what would it be if it was a little bit off? So it's still diagonal, but it's not quite from end to end. So go a little bit off from end to end. What shape would that give you? It's not a triangle, it's a trapezoid. All right. Okay, so that one didn't actually have you write anything down, but now let's try a cylinder. So go through, take a minute for cylinder and find all the different cross sections. So click on cylinder, Go through all the different cross sections. So go through a cylinder, go through all the different cross sections. So everyone should be on cylinder. Everyone should be looking through all the cross sections. Oh, there's plenty of cross sections. And I will be calling on people's names. So you need to be working on this. Now, if you don't know what this shape is called, draw a picture of it.
Is this a shape? I swear it's some universe.
When in doubt, this one.
That's a shape, right? Yeah.
Just get it as fast as you can. So just get it as fast. Stop. Just offset. So it's still really vertical, you just offset. So you're right now it's going to center. So just take it back. Slide it offset. So grill the base first. So the base will be the circle. So then you
I'm going to be honest, I don't have your. I have it in my before you throw it back.
Alright, thumbs up if you're ready. It's still completely vertical, it's just not going to the center. So now it's a little offset. Yeah. Yes. So unless you get 100% go to those sides, zero it. Alright guys, thumbs up if you're ready. Give you a couple more minutes. Now, if you're waiting to move on, try one of the other shapes. So, Harold's
Like really
It's
That one, right?
That's wrong.
Yeah. Like diagonal. All right, guys. So let's talk about this. So let's go with Carter. What'd you get for? So for a cylinder, when it's parallel to the base, it is a circle. Good. So if it was parallel to the base, which it already is, definitely a circle. All right. Now let's go with Aiden. Vertical through the center. What'd you get? Good. It should have been a rectangle. So if I cut it completely vertical through the center, rectangle. All right. What about perpendicular, not through the center? So still vertical, just not through the center. Emery. So it would be a rectangle. You could say it was a square, but you'd have to be like 100% certain. So if we just offset it a little bit, still a rectangle. All right. Okay, diagonal. Now, the answers could kind of vary here. So Sophia, when you okay. Yeah, so if you cut it diagonal, it does not have to be perfect. All right. But if you cut it diagonally, you would get an oval. All right. Now, some of the other shapes you could have gotten. So, the only other shape that you could have gotten is if it looks something like this. All right. This is what we call a hyperbola. All right. Hyperbola. All right. You don't really need to know that. It's just so you know, that's what that shape's called. All right. All right. Last one we're going to do. Let's do a cone. So take a minute. I'll give you guys about 2-3 minutes. Try a cone. Hyperbola. HYPR. So again, if you don't quite know what the shape is called, just take a best guess of what it looks like.
I got that.
An oval? But it has like the level too.
Yeah, but if you look at it.
That's my shape.
Around.
That's a hyperbola. Just do Yes. I would.
That's all I put.
All right, thumbs up if you're ready. I'll give you guys one more minute.
I'm so sorry.
Just offset it slightly. So it's completely vertical, but you just offset it. All right, let's come back together. Shh. All right, hush. Let's go with Nolani. Parallel to the base. Circle, good. So you look at the cone, it should already be parallel to the base. You from the cross section, it's a circle. All right, let's go with Paula. So vertical through the center. So in other words, it's going through that point of the cone. It'll be a triangle. All right. Tobias. So perpendicular, but not going through the point. All right, so let's look at it. So I'd want it completely vertical, but it's not going through the point. So right now it's going through the point, so I'm going to move it so it's off center a little bit. It's a hyperbola. All right, so it's not triangle because of that curve. This is what's called a hyperbola. Hyperbola. That's how you spell it. All right. Now, diagonal. Let's go. Fatima, what'd you get for diagonal? Oval. So if you cut it diagonally, and it doesn't have to be perfect, all right? All right. It would be an oval. It's not quite a circle. It's a little bit more elongated, so it's an oval. You could also say ellipse. An ellipse is another way to say oval. Ellipse. All right. Now, without even testing them, all right? So if we were given a square pyramid, without even testing them, let's see if we can make some assumptions. All right. So a square pyramid, if I cut it parallel to the base, so I cut it right through here, and I looked at it dead on, what shape do you think I'm going to get? Good. The base of a square pyramid is a square, so you get a square. What if I did vertical through the center, so it's going right down the middle? Triangle. What about if it wasn't through the center? Any guesses? So it's not going through the tip. This would actually be a trapezoid. Because if you draw it not going through the very top, all right, it basically you're just cutting the tip off. All right. Hush, I know what I said. Shut up. All right. Now, diagonally, there's a couple of things you can get. You can either get a rectangle or a trapezoid. You're not going to get quite a square. All right. Now, what about a sphere? What do you guys think is going to happen for a sphere? They're all going to be circle except one. Which one do you think? It's the diagonal. So as soon as you cut a sphere diagonally, it would be not quite a circle. All right. It would be more of an ellipse or an oval. All right. Ellipse. All right. So basically, guys, when it comes to cross sections, that's all I'm going to ask you. I'm just going to ask you what's the cross section. All right. The biggest thing is you have to know is you need to know the difference between parallel to the base, perpendicular to the base. All right. So parallel to the base means exactly what it means. It's not going to go through the base. All right. Perpendicular to the base, it will go through the base, but it's completely vertical. All right. All right. Any questions on this activity? All right. So go ahead and close your Chromebooks for right now. We don't need it anymore. Now we're going to take the formal notes. So now go back to page 5. So the front of the packet. All right. So these are pretty quick. It's just going to kind of recount what we just said. All right. So, So a prism is a solid that has two congruent faces, and we call those the bases. All right. All other faces being parallelograms, typically we'll see them as rectangles, but they're parallelograms unless they're what we call right prisms. Now, right prisms, think right triangle, all right? Why do you think those two prisms shown right there are right prisms? What kind of clues you in? What are the faces that are not the bases? They're all rectangles. So these are rectangles, these are rectangles. So why do you think they're called right prisms? What's true about a rectangle? Right angle. So the faces that are not the bases are rectangles. All right. Another way you could think about it is that if you found the center point of the face for both of them and you drew a line, it would give you a right angle for both of them. All right, so if you found the center point of both bases and drew a vertical line to it, it would form a right angle with that base. All right, that's another way you can think about it. Now, if we sliced this prism through a horizontal plane, all right, so in other words, it is parallel to the base. All right, so if you look right here, here's the cross section. All right, so right here is the plane that we just cut through. What do you think the cross section would be? So when we did our activity, every time we did parallel to the base, what typically was the shape? Whatever the base was. So what's the base of this prism? It's a hexagon. So what do you think the cross section is going to be? A hexagon. So typically, if it's parallel to a base and it's a prism, it's going to be whatever the base is. That's going to be the cross section. So whatever type of shape the base is, that's going to be the cross section. Now, a vertical plane. So it's cutting through a prism vertically. So here is the plane that we're using to cut through. This is a triangular prism. So in other words, we're cutting perpendicular to base. which for every prism that we did, when we cut it vertically perpendicular to the base, what was always the cross section for every prism that we did? It was a rectangle. All right. So that would also be this cross section, a rectangle. So if you're cutting a prism, just a prism, any type of prism, if you cut it vertically or perpendicular to the base, it'll give you a rectangle. So if I cut this one vertically, all right. So if I cut this one vertically, so let's just say this line is my plane. What shape do you think you'll get? A rectangle. All right. Now, cylinder is a little bit different. So a cylinder is a shape that's very similar to a prism, except the base is enclosed in a curve rather than a polygon. And so that curve is a circle. Now, a right cylinder is essentially the same thing as a right prism. All it means is that if I drew a vertical line from the center of each circle, and then I drew the radius of one of the circles, it would form a right angle. All right. So what are the two measurements that control its size? What are the two measurements I just drew? Not the base, the radius and the height. So with a cylinder, what controls how big it is its height and its radius. Which, when we get to some volume of this stuff, if you notice the volume of a cylinder is pi r squared h. Radius and height, that's true with the volume, so that's why it's included in the volume, because the height and the radius control its size. Now, what two-dimensional shape wraps around the surface laterally? So, in other words, what it wraps around laterally, okay? So, laterally means horizontally. So, if I cut this circle parallel to its base, what's the shape? Circle. All right. Now, a two-dimensional figure, when rotated on one of its sides, produces a right circular cylinder. What do you think that figure would be? So in other words, guys, what that means is if I take a 2D shape, and we'll talk about more about this tomorrow, but if I take a 2D shape and I just rotate it on its side, it'll create that cylinder. Any guesses on what shape that would be? It'll be a rectangle. So in other words, for example, let's say that I took this sticky note, okay? Stuck it to my pen. All right, this is a rectangle. I'm going to rotate it on its side. If I just rotate it all the way around, it will create that cylinder. So all I'm doing is just turning it in a circle. So the shape that it will create in the end would be a cylinder. All right. So this is actually called a solid of revolution. We'll talk more about that tomorrow. All right. But you just need to know that it's a rectangle. Because again, let's just say I had a plane. Let's just say I had a rectangle here. And I rotated it all the way around. So it would create that circle on both sides, which if I then drew the line, there's your cylinder. All right. Now, a pyramid. So a pyramid is a solid where one face, known as its base, is a polygon and all other faces are triangles that meet at a common vertex. So a horizontal cross section of both of these bases would not be congruent to their actual base. So far, all the ones that we've done so far with prisms, and we cut it through, same thing with cylinders, we cut it parallel to the base. That shape was actually perpendicular to the base. Why would a prism, if I cut it horizontally, so here's my base, all right, but here's my cross section. Why would this rectangle or square not be congruent to this rectangle or square? So think about it logically. What's the other faces made up of? Triangles. All right. What were the other faces of the prisms typically that were not the base? So prisms, what were typically the faces that were not the base? What shape? Rectangles. All right. So with rectangles, it pretty much stays the same width all the way up. What's true about triangles? Does it stay the same width all the way up the triangle? No. That's why. All right. So it's because it does not stay the same width going up a triangle. However, these shapes do have some relationship to them. So they're not congruent, but they could be what? So when you were in math 2, you learned about congruent triangles, and you also learned about what type of triangles? There's another word. Not isosceles. Not right. So relationship to it. So congruent is same size, same shape. This word I'm thinking of just means it's the same shape, but it's not necessarily the same size. Does anyone know what that word would be? Starts with an S. Nope. I heard it. Nope. You guys remember similar? So, in other words, they create a shape similar to the base. And all similar means is same shape, but not necessarily the same size. All right, so congruent means same shape and same size. Similar just means it's the same shape. Now, under what conditions would the triangular sides of the pyramid all have to be congruent to each other? So in other words, of these two pyramids, so this base right here is a pentagon, and this base right here is either a rectangle or a square, we don't quite know. What would make all of those triangles going around that base the same size completely? What would have to be true? Think about in terms of the base. Say that one more time, I might just hear you. Not necessarily. So in other words, all the other faces or the triangles going around the base would be the same size triangle all the way around.
It should only have 3 sides. Wait.
So in other words, what would make this side the same size as this side? How can I guarantee that those two triangles are the same size? The base, all sides of the base would have to be congruent. That's so all edges dash sides of the base have to be congruent. So in other words, this would have to be a square. This would have to be what we call a regular pentagon, meaning all the sides are congruent. All right. Okay, good God. Now, the last shape we're going to talk about is a cone, which is very similar to a pyramid, except the base is a circle. All right, so the only difference between a cone and a pyramid is the cone's base is a circle. All right, typically a circle if it's a right cone. Now, similar to a cylinder, a cone can be produced by rotating a common two-dimensional shape around one of its sides. So, we got a cylinder if we rotate a rectangle on its side. What shape do you think you would get? Or what shape, if you rotate it on its side, do you think would give you a cone? I heard it. It's a triangle. All right. So if I drew it, so let's say this is like my axes, and I have my triangle right here. If I rotated that triangle all the way around, so like this, it would create that cone. All right. So it would be a triangle. That's also the cross section you get when you cut through the center vertically. Last thing we're going to do is describe these cross sections. So this one is horizontal to the base. So what do you think that cross section is going to be? Circle. If it's horizontal to the base, it's a circle. Now, this is diagonal to the base. That'll be an oval. You can also call that an ellipse. You may see it as ellipse, so I would write that down. So the fancy math word for oval is called an ellipse. Now, this shape right here, what did I tell you that's called? Hyperbola. And then lastly, if you cut it right down the middle, it's going through the center of that circle. Triangle. So, you guys need to be familiar with these shapes. Any questions on cross sections? Not too bad, right? Cross sections are probably one of the easiest topics in this class. All right. Now, listen up. So here's what we're going to do. That journal entry, we are not going to go through together because it's just a restating of everything we just did. So you still got to do it on your own time. It's already posted in Canvas. So if you want to go ahead and knock that one out, you can. I'm about to tell you what we're going to do. So now, Now, I will give you a break. When you come back, there are two assignments for you guys to do. There's a Delta Math as well as a quizzes on cross sections. Most of it's just going to be, can you figure out what the cross section is? All right, that's it. All right, so that's what I expect you guys to do. So when you come back from break, you can work on either your journal or those two, the quizzes and the Delta Math. All right, so I'm going to give you your break. When you come back, that's what you're going to be working on.